Hi, welcome back to part two. Part one we looked at the new feature added to System View 2020 Update 1 regarding overlapping subarrays and the ability to do custom mapping across the beamformer weights, splitter imp, and the combiner matrix part. And we showcased that in the stock custom mapping example. This time, and this is what it looked like. This time I made some modifications, and I'm going to provide that example. It's called MK2 custom mapping. So let's take a look at that. So it's basically the same design, but let me show you what's different. So there's a few things that are different. Number one, the stock example was two subarrays that were 4x3 subarrays, and that was set in the setup equation. And that's what we did here. I commented that out and I refashioned them to be two 5x5 subarrays. We still build the element map the same way. I just changed from a 4x2 4x3s to two 5x5s. So the result of that is, this methodology of how that's put together visually is still the same, but instead of two 1x12s, we're going to get two 1x25 structures. So the resulting map will end up being a 1x50, right? As you see here, element map 1x50. And so that's a change. The other change is I did add a phase shifter in here. I didn't have that before because I want to compare, the beam from the directly from, again, I'm going to look at the far field beam projected from the beamformer weights. I added a node there called weights, and you could do that by any node. You can right click and say net, edit net name, and you can add a node name, or you can make that a bus. I'll show you a bus in a little bit. So I added a weights there, and I'm also going to look at the far field beam after the, in our actual phase array design. I'm going to look at that after the amplitude tapering is done, and with a node called 3D beam pattern. So that's a change. I did change the direction. So if I go to the beam, if I go to the beamformer weights, if I go to the beam configuration, I did change the directions for user 1 or user 2. So now I'm going for user 1 45 degree theta 0 phi, and user 2 is 45 degree theta 185. So that's a change. And then to project the far field beam at those two different points, right off the beamformer weights, kind of the ideal beam that's tied electrically to the weights node. I have that on the top, and on the bottom, it's basically the same thing, but I'm getting it from the 3D pattern. So right from our beamformer phase array transmitter design, right after the amplifier _m part, and what does that give me? So let's first talk about what's going on here that's common. There's a few differences between the two, and I'll talk about that in a sec. But what's common? So what's common is on the MK2 Custom Mapping Design 2 version, I basically take the signal coming in, and I basically unpack it. And so in this case, it's two 5x5 arrays. So I basically unpack it in rows of 25 in column major fashion. So I break it into two parts, I break it back into the two subarray columns, and then I break that matrix into kind of a string that I can distribute. So I distribute in blocks of 25. So each block size of 25 is like a subarray because it's a 5x5 array. And so I basically declared, here's where I declared a bus. I used an unpack, and then I used a distributor, and at the output of the distributor, so it's going to go through 20 blocks of 25, and it's going to distribute those out in a bus. So first it goes to user 1, and it distributes that there, and then it goes to user 2 after it gets through the subarray 1, 25 blocks. It goes to, and does subarray 2, 25 blocks. And so then I use a pack M matrix block. Before I used unpack, now I'm using pack to reconstitute those 5x5 matrices. And then I add them back together, and I put them in the beamformer part, the beam pattern part that's going to basically project the far field beam. And I can, and I'll show you that in a sec. So, you might be asking yourself, well, why in the world would you, unpack, distribute, repack, and then add it back together to get the same thing? Well, I could have just done the beam pattern right off of that point and got the results. Yes, I could. But the reason I did this is to show, I'm going to show you this in a sec, the ability to turn on and off a different subarray and see the effect, right? This is the what-if power of a system design tool like System View. And so I'm going to basically show that. So these parts that I just walked through here are also in the other design where I'm picking off the actual, the 3D pattern node. And those are all the same. But what's different? What's different between these two? On the first one, where I'm projecting the ideal beam, far field beam from the weights directly, I'm gonna put data sinks on the phi, theta, antenna gain and capture that data. And then I'm gonna do a static plot. I'll show you that in a sec. But I basically use a MATLAB equation to create this static plot shown here on the right. And so it's taking the output of those sinks, phi, theta, directivity, basically using a add spherical data, a MATLAB 3D graphical function to create this plot. And that's what I do there. So let's go back and what's the difference here? So because I'm getting data here, colors mean things in System View. They mean types of data. So because I have a thick black pin here, this is a matrices because it's thick. Because it's black, it's timed envelope data. And so because of that, if I want to project the far field, I need to basically convert from envelope to complex. And then I can use the same thing I did before with the weights. So I use a ENV to CX to convert back to complex format. And then I basically have the same things we walked through before, the unpack, the distributor, the pack, and then add it together in the beam. Same exact thing to get the beam, but this time instead of a static plot, I added a dynamic 3D plot to get the a dynamic version that basically renders. You can add markers, look at the 3D beam when the simulation's running, which is also kind of nice to do. And I set this up to do spherical coordinates, dB magnitude, and you can set a threshold which affects the colors and the dynamic range of the scaling. So let's run this. Okay, so if we run this with everything connected, I have all of the subarray 1 and subarray 2 connected with the overlapping custom overlapping mapping that I set. What happens if I run it as is? It runs very fast, and I get this plot for what's coming off the beamformer weights. This is the kind of the ideal beam projection, and if I run it, I get a dynamic plot from directly off of our transmitter phase array beamformer, and this is what I get here. It's a little different because we're going through the phase shifter, the amplitude tapering, but very, very consistent. And I can on any of these 3D plots, I can right click and I can add markers, and I'll let you play with that. You can look at different views. You can zoom around. So let's stop that. So that's the comparison between when both are on. Now what happens? Let's do some what ifs here. That's the power of this tool. So if I delete the effect of one of the subarrays consistently in each, I should get consistent results, right? So if I run this, now what do I see? Now I have to run it one time to have the static plot update, and it does. So now let's run it again and just compare the dynamic plot with it. So if I put a max marker on here, you'll see that it goes to phi, really 0, which is 300, 0 degrees is 360 degrees. So phi 0, theta 45, I get a magnitude of 11.52. And I get the same thing on the static plot from the weights. 0, 45, phi theta, I get 11.52. Very interesting. That's one of the directions for user 1, I think it is, that we had. Now what happens if I do Control Z and bring back my lines, and now if I negate the effect of the other subarray just by deleting a line in this case, which I could make programmatic if I wanted to. Let's see what happens now. So I run it, runs very fast. I stop it, it updates the plot. Let me run it again just so I can show you comparing the dynamic plot with the static plot. And once again, I get the intended other direction, right? I get 185, 45 degrees theta, and it matches exactly. So hope you had some fun. Go off and play with that and do a lot of what ifs and have fun with the new overlapping subarray custom mapping feature of System View 2020 Update 1. Thanks.